Good morning students, second PG students. Listen, today we are going to see the 5th unit Hadoop and Big Data and its introduction. In our traditional approach, an enterprise will have a computer to store and process big data. For storage purpose, the programmers will take the help of their choice of database vendors such as Oracle, IBM, etc. In this approach, the user interacts with the application, which in turn handles the part of the data storage and analysis. See here, we are having the centralized, the user and interconnected with the relational database. This is our traditional approach. So in this traditional approach, an enterprise will have the computer to store and process big data. For storage purpose, the programmers will take the help of their choice of database vendors, maybe Oracle, IBM, etc. This is called the traditional approach. So now we are going to see why we need the Hadoop. But this approach, that is the traditional approach, works fine with those applications that process less voluminous data that can be accommodated by standard database servers or up to the limit of the processor that is processing the data. But when it comes to the dealing with the huge amounts of data, scalable data, it is a hectic task to process such data through a single database bottleneck. So Google solved this problem, this traditional problem, using an algorithm called MapReduce. This algorithm divides the task into small parts and assigns them to many computers and collects the results from them, which when integrated form the result dataset. This is the solution for this problem, that is with the MapReduce algorithm. Google solved this traditional problem. That's why we need the Hadoop. See, centralized system user with commodity hardware. So the diagram explains the commodity hardware connected with the centralized system with its user. Using the solution provided by Google for this traditional approach, Doug Cutting and his team developed an open source project called Hadoop. Hadoop runs the application using MapReduce algorithm where the data is processed in parallel with others. In short, Hadoop is used to develop applications that could perform complete statistical analysis on huge amounts of data. See, the Hadoop framework, the user, Hadoop framework with the big data. So anyway, the big data is also connected with this framework. Here MR represent the MapReduce algorithm. User, in this Hadoop framework, we are having the MapReduce algorithms. It was connected with the big data. In the big data, we are having media data, system log file and relational database. This is called the Hadoop framework. Okay, what are the advantages? What are special? What are the plus points of Hadoop? Here, servers can be added or removed from the cluster dynamically and Hadoop continues to operate without the interruption. So another big advantage of Hadoop is that apart from being an open source, it is compatible on all the platforms since it is Java based. It's very important because it is Java based. So it is compatible on all the platforms. And Hadoop framework allows the user to quickly write and test the distributed system. It is efficient and it automatically distributes the data and work across the machines. In turn, utilizes the underlying parallelism of the CPU cores. It's very important characteristics, that is parallelism. Hadoop does not rely on hardware to provide fault tolerance and high availability. FTHA. So it is not relying the hardware only. Rather, Hadoop library itself has been designed to detect and handle the failures at the application layer. It's very important characteristics. In the application layer, Hadoop having a library itself has been designed which is used to detect and handle the failures. Servers can be added or removed from the cluster dynamically, and Hadoop continues to operate without any interruption. This is the advantage and speciality of the Hadoop. This is the architecture. We are having 4 layers. First one is called the MapReduce algorithm or distributed computation, Hadoop distributed file system, HDFS distributed storage, and we are having another YARN framework and common utilities. See this diagram. We are having 2 major layers, namely MapReduce, that is for processing or computation layer. Next is storage layer, Hadoop distributed file system, HDFS. See here, HDFS and MapReduce. So MapReduce is parallel programming model for writing distributed applications devised at Google for efficient processing of large amounts of data, that is multi-terabyte data, on large clusters, thousands of nodes of commodity hardware in a reliable, fault-tolerant manner. The MapReduce program runs on Hadoop, which is an Apache open source framework. So MapReduce is a parallel programming, and it is efficient processing of large amounts of data. That is very important. So this MapReduce program runs on Hadoop, which is an Apache open source framework. HDFS, Hadoop distributed file system. It is based on Google file system GFS and provides a distributed file system that is designed to run on commodity hardware. It has many similarities with the existing distributed file system. However, the differences from other distributed file systems are significant. It is highly fault tolerant and is designed to be deployed on low-cost hardware. It provides high throughput access to application data and is suitable for applications having large data sets. It is called the Hadoop distributed file system. So we are having the modules Hadoop Common and Hadoop Yarn. In Hadoop Common, they are Java libraries and utilities required by other Hadoop modules. Hadoop Yarn, this is the framework for job scheduling and cluster resource management. See here the diagram. We are having Yarn framework and common utilities. How it is working? Data is initially divided into directories and files. Files are divided into uniform sized blocks, that is 120 M, 64 M, preferably 128. These files are then distributed across various cluster nodes for further processing. Hadoop distributed file system, being on top of the local file system, supervises the processing. Then blocks are replicated for handling the hardware failure, checking that the code was executed successfully. Then performing the sort that takes place between the map and reduce stages, sending the sorted data to a certain computer, writing the debugging logs for each job. In this way, the Hadoop's working. Okay, so far we are dealing with what is Hadoop, advantages, traditional approach, Hadoop framework, Hadoop advantages, its architecture, its layers, MapReduce algorithm, how it is working, its modules. Now we are going to see the another part, big data. Big data and Hadoop is a software framework that enables the processing of large data sets in a distributed computing environment. It is designed in a way where it can scale up from a single server to thousands of machines, each offering local computation and storage. What is the we are going to see the big data and Hadoop, the relationship between big data and Hadoop. Big data and Hadoop are the two most familiar terms currently being used. Both are interrelated. in a way that without the use of Hadoop, big data cannot be processed. Big data is a term used for the collection of datasets that are large and complex, which is difficult to store and process using available database management tools or traditional data processing applications. The challenge includes capturing, storing, searching, sharing, transferring, analyzing, and visualization of this data. This is the relationship among big data and Hadoop. Actually, big data cannot be processed without Hadoop. What are the tools of big data? Data storage and processing, data analysis, real-time processing, NoSQL database, data warehouse, messaging system. Now we are going to analyze the big data and Hadoop with this 4 features: the definition, significance, storage, and accessibility. Okay, first the definition. What is big data? Big data refers to a large volume of both structured and
connection to the internet. Please try again a bit later.
Big data refers to a large volume of both structured and unstructured data. But Hadoop is a framework to handle and process this large volume of big data. Significance. Big data has no significance until it is processed and utilized to generate revenue. Hadoop is a tool that makes big data more meaningfully by processing the data. Storage. In the storage, big data is very difficult to store because it comes in structured and unstructured form. Apache Hadoop, HDFS, Hadoop Distributed File System, is capable of storing big data. The last point is the accessibility. When it comes to accessing the big data, we know that it is very difficult. But in the Hadoop framework, lets you access and process the data very fast when compared to other tools. Thank you.